Augmented reality is coming at us fast. Every large tech company is rumored to be building an AR product. Microsoft HoloLens is already available to developers. Pokemon Go, the most popular augmented reality product today, was made by a company that was spun out of Google. But Apple seems to be ahead of everyone. Apple's ARKit is a set of tools for developers to build augmented reality applications. The applications people are building with ARKit are remarkable, and two of those early adopters who are building applications joined the show today for an interview. Jesse Bounds and Siyu Song work at Mapbox, a company that makes mapping, navigation, and location search SDKs. Location is a natural companion to augmented reality. If I'm walking down the street with a pair of augmented reality glasses on, those glasses can augment the world with information based on my location. Because the fit between AR and mapping is so natural, Mapbox has been rapidly experimenting to build up an expertise in AR. As a result, Jesse and Siyu make for great guests to talk about what engineers can build with ARKit today and what might be possible in the future. Developers love Docker containers because they give applications portability and consistency all the way from your laptop to production. But things can get complicated fast when the time comes to deploy, manage, scale, and secure containerized apps in the cloud. Amazon EC2 Container Service from Amazon Web Services makes it easy to run Docker apps in production. With Amazon EC2 Container Service, installing, updating, operating, and scaling your infrastructure happens automatically. Using simple API calls, you can launch and stop Docker-enabled applications, query the state of your cluster, and natively integrate with powerful AWS services like security groups, elastic load balancing, EBS volumes, and more. Best of all, you only pay for the AWS compute and storage resources you use. With Amazon EC2 Container Service, you can focus on building apps, not spending time deploying, scaling, and managing your container infrastructure. It's time to get back to what you do best. Learn more about Amazon EC2 Container Service at ecs.aws today. That's the letters ecs.aws. Jesse Bounds and Siyu Song are engineers at Mapbox. Guys, welcome to Software Engineering Daily.
Thanks very much. Thanks for having us.
Thank you.
Yes. So I'm excited about this episode because this is the first one we've done that touches on augmented reality. So I don't know how deep we're going to go today because I'm going to do a lot of shows on augmented reality in the future, but I'd certainly like to at least get an overview and talk about some of the applications you guys have been seeing, what you've been tinkering on, and your thoughts on the future. Just to level set, let's just start off by exploring what is augmented reality and what are some of the applications for augmented reality.
Well, I think traditionally it was a term to describe some artificial interface sort of laid over the real world. And kind of, I think more modern augmented reality kind of came around in the late 90s with lines over sports fields, like the 50-yard line in football games. And kind of fast forward to the future, more recently, we've seen libraries by Google and other companies and devices that to allow you to do just that. And then, of course, more recently with ARKit and Apple kind of getting into the game with a library really specifically designed to enable developers to sort of inject this digital content into the real-world space.
Yeah, and just anecdotally, I personally think about it in terms of like things such as heads-up displays that you see in video games and like movies, but being able to do that with like real-world data and things that your device camera can see in your like immediate future, like in your immediate surroundings.
I felt like Pokemon Go was the first big augmented reality in your face kind of application. What do you think were the takeaways from the explosion of Pokemon Go? Did that thing take off because people were just so fascinated by the augmented reality aspect of it, or was it the virality of the game? What are the lessons there?
Yeah, from a gaming perspective, I think the kind of general consensus was it was kind of this alchemy of a different type of gaming experience combined with the like unique IP of Pokemon, with generally the nostalgia around it and kind of the aesthetics of it. Things that we've seen before. For instance, the company that made Pokemon Go made had a very similar game called Ingress with elements of AR and location based like points of interest collection, similar to Pokemon Go, but it didn't catch on in the way that Pokemon did. So, in terms of gaming, kind of what we're seeing the trend is that both Pokemon Go is unlocking a combination of like augmented reality games and unlocking a lot of IPs in combination with augmented reality games.
Let's set the stage in terms of the hardware and software. What are the advances in technology, fundamental technology, that are enabling this augmented reality to make its way into the masses today?
I think for the most part, it's sensors, camera and motion sensors on devices. There have been some companies like Occipital that have been in this space for a while. They, I think just last year, released a headset with a sensor bridge on it that allows you to do some pretty amazing things, very similar to what you can do with ARKit, for example. But I think bringing it to the masses is starting to happen because the devices, the phones that people carry around in their pockets have sensors that work well enough, and then add on top of that computer vision and algorithms and chips that can do those calculations quickly enough to sort of calculate the device's bearings and relation to where it is on the starting point in the real world space. And it really brings that technology to people, sort of like phone cameras did a decade ago. Kind of interesting to see.
Yeah, from a numbers perspective, the thing that's really exciting is that when iOS 11 launches, there will be something like 160 million AR, like natively AR-enabled devices just out there. So creating that install base, I think, is one of the most exciting things about this particular push.
I've seen all these videos online of ARKit, the preview stuff of ARKit. So I think where we are today with ARKit, actually, I guess we should just start by, why don't you guys explain what ARKit is?
Sure, I can take a shot at that. It's an SDK that Apple launched at WWDC a couple months ago that wraps up sort of the computer vision and camera sensor features combined with core motion into a set of pretty easy to use APIs that allow you to start a session. So it's a session-based API. You can start a session. You can then monitor the state of that session, and when it discovers its bearings in a 3D space, it'll call back to the application code, and then you can use any number of sort of rendering 3D content creation or 2D content creation engines to inject your own content into the scene and anchor it to points and planes in the scene that ARKit has discovered. And of course, it handles I think probably maybe just as importantly, it handles the movement of the device after the session has started, so it keeps your digital content locked to anchors in the scene as you move around, which gives the illusion that the content is really there as you move around a table or have the content animate around in the room.
So what I've heard is that the next iPhone is likely going to have some laser systems and some more advanced sensors, and that's going to make it even easier to track stuff around the room, like track horizontal planes around the room so that you could display something on top of that horizontal plane, like a dancing hot dog or a piece of furniture, whatever would make useful sense depending on your application. It's going to get easier. But today, it already looks pretty good. The stuff looks pretty good. So is the current model of detecting a scene or understanding the scene, it's all just computer vision? Is it more computer vision than it is about sensors and depth?
I think it's both working in concert. So the computer vision part comes in the context of recognizing a scene and getting the initial bearings, and recognizing that there is a horizontal plane there. There's a table in the room, and there's an object on that table, and there are points on the on the object that are closer to the camera than the table itself, and just kind of creating that's called a point cloud. So establishing that point cloud and optionally horizontal surfaces. And then the motion sensors come into play once you start moving around the scene. So that helps you maintain the location of content in the scene as you move, say, 2 meters backwards from where the session started, or in whatever direction, up or down, and as you rotate the device around 3D space. So the motion sensors feed into ARKit to allow it to do that part.
Yeah, and thinking blue sky like far into the future, the ways that this could be even more enhanced is to have better just awareness of on the device of what the environment looks like. So right now, in terms of image detection, mostly it's been focused on like rectangular surfaces for like tabletops, but being able to get like a 3D volume of your environment or the room would definitely be kind of like the holy grail of, at least from the hardware and software side, being able to do, like very in-depth, like high fidelity simulations.
We've talked about some of the abstractions that we need to be concerned with here: horizontal planes, sessions, scenes. Could you introduce us to the vocabulary that we need to know to understand and talk about augmented reality?
Do you mean the vocabulary in the context of the ARKit SDK specifically, or just more generally?
I think both.
Sure. Well, the ARKit API, like I mentioned, is a session-based API. So you configure a session instance and pass in a configuration. And the configuration allows you to specify things like what kind of tracking. Tracking is another keyword here you want to do. And there are 2 types of tracking available, and they relate to the degrees of freedom that the device can track in. So 3 degrees of freedom can be achieved on any device that supports ARKit. So we're going back to 6S's and I think the A9 chip. So on those devices, you can at least look around. So you can kind of have you can imagine a stationary camera and have it look around in the space. And then more modern devices with faster chips can be configured with a 6th degree of freedom session, which would allow you to not only look around from a singular point in the space, but also move back and forth in it, sort of like we were talking before. So that's the session. In addition to session, there are objects called anchors, which are really key, I think, because the anchors, you can hit test for them. So you can touch touch a 2D space on the screen of the phone and hit test for anchors in the 3D space, and then get a set of anchors back, sort of ranked from like farthest away to closest to the phone, and then use those anchors to attach your 3D content that you put into the scene. I think beyond that, you start to get into some of the things that ARKit doesn't do. So to me, ARKit is a little bit lower level in an application stack, and it's kind of this missing piece that we didn't have for mapping the digital content in the 3D space. But it relies on plugging things into it for graphics. So an obvious one would be Scene Kit or Sprite Kit for 3D or 2D graphics, respectively. And then also, if you want to do something with geospatial, like latitude, longitude, injecting content into the scene, not just in meters away from where you are, but translating a latitude and longitude to a distance in meters away from the scene. That's the kind of thing we're thinking about. But it gets really interesting when you start thinking about what you can plug into it, which kind of leads to Unity, which is what we've been working on here too.
Yeah, and speaking, I guess moving up a little bit in the stack towards like content creation, like kind of the glue that this allows us to delve into is doing like more traditional like CG, computer graphics, 3D animation type techniques. Thinking about the ARKit camera in terms of your 3D camera, there's a nice level of abstraction where setting up an ARKit camera within a video game engine like Unity, you're allowed to treat it kind of like you would any other video game camera as a thing that moves in 3D space, and you set up a 3D environment around that camera, and all the content kind of locks into place. And so I think in terms of vocabulary and things to think about as we're creating 3D or AR content and AR applications, one of the things that will be interesting and exciting is like there are a lot of like techniques and methodologies for animation and video game creation that will kind of overlap very nicely for AR content creation.
Grammatech Code Sonar helps development teams improve code quality with static analysis. It helps flag issues early in the development process, allowing developers to release better code faster. Code Sonar can easily be integrated into any development process. Code Sonar performs advanced static analysis of C, C++, Java, and even raw binary code. Code Sonar performs unique data flow and symbolic execution analysis to aggressively scan for problems in your code. Just like battleships use sonar to detect objects deep underwater, engineers use Code Sonar to detect subtle problems deep within their code. Go to go.grammatech.com/sedaily to get your free 30-day trial exclusively for Software Engineering Daily listeners. Code Sonar analyzes your code, and it delivers a detailed report. The Code Sonar user interface provides all the information that you need to quickly understand the reports, follow cross-functional paths, understand cross-references, quickly navigate between files, and visualize large pieces of your code. Go to go.grammatech.com/sedaily to get your 30-day free trial and unleash the power of advanced static analysis. Thanks to Grammatech for being a sponsor of Software Engineering Daily. Okay, well, we'll move up the stack in more detail in a moment. I'd love to get both of your subjective experience working with ARKit or working with augmented reality on Apple devices. You know, I think we have different experiences with different frameworks that we used for the first time. I know the first time I used a certain framework that I'm just not going to name because I don't want to insult anybody, but it was really painful. You know, and then the first time I used React, it was really fun and pleasurable. It just totally depends. So what has been each of your experiences getting acquainted with ARKit?
Yeah, I think maybe I'll go first because I've been working with ARKit a little bit more directly than what we do in the Unity space here. But I don't know. I'm an iOS developer in part because I really enjoy working with Apple APIs and SDKs. I find them usually to be really well designed and nice to work with. And ARKit is no exception. I think currently the surface area of the API that you have to learn and understand is relatively small. It does what it does really well. And like we were talking about before, there's these notions of session and anchors, and then it really delegates to other libraries. So the complexity would come in matrix math utilities for transitioning objects around in the scene and using an entirely different library for graphics rendering. But at the ARKit level specifically, yeah, I found it to be really a joy to work with and to work surprisingly well. Like compared to some other similar libraries that I've seen, and I haven't worked with all of them, but experiences that I've seen on the internet from other projects like what Google has with Tango and even some of the other dedicated hardware experiences. It works as well as most of the time as the other dedicated, more expensive hardware that is really unwieldy compared to just the phone device that you have in your pocket already.
Yeah, and speaking from the Unity side, I started working with ARKit via the Unity ARKit plugin. So it's essentially bindings in the game engine directly to the ARKit SDK when you build out to an iOS device or application. And yeah, I found the experience to be pretty enjoyable, like pretty easy and painless. The workflow generally is that you treat kind of how a Unity or game developer would interface with ARKit is that you treat this ARKit camera as your game camera. And so once you have that camera in place, you build your scene around that. And some of the challenges that we ran into were mainly with like world scale. Scaling of your objects in 3D is different when you are making like a traditional game that's played on directly on the phone that's not AR, you can kind of have full control over what the units mean. But when you're working with ARKit, special considerations for the units in the game engine being real world units and how that affects things like shading and lighting models are things that we have found that we have to consider. Not necessarily entirely new challenges, but just like a specific subset of graphics related things to keep in mind as you work in ARKit.
Yeah, it turns out a 3-meter cube rotating in your living room is really, really big. Yeah. And sometimes it's disorienting as you're learning and experimenting with it and playing around. Something Siyu just said kind of reminded me, some of the limitations that I've found so far are dealing with occlusions, and the illusion of the content can get sort of ruined when you can see it through something that's physically in the room that you would normally, if it were actual real content or a real thing in the world, you would expect to be hidden by the other thing in front of it.
Can you give an example of that?
Yeah, sure. So there's actually a good example of someone working around this using horizontal plane occlusion, which you can do now. But the example would be like maybe you build a little app with a robot that travels around on the floor, which is one horizontal plane, but it moves under the table, which is another horizontal plane. And unless you write code yourself to stop rendering the robot when it moves under the horizontal plane that's closer to the camera than the floor, you'd still see the robot through the table. So it kind of wrecks the illusion that the thing is actually in the room when it starts to bleed through the other real world objects.
Yes.
And that is again sort of solvable for objects in the same room as you if the objects are horizontal surfaces. But I think you mentioned before the rumor of new hardware this fall with the laser on it would potentially allow for vertical plane detection and therefore vertical plane occlusion, which would be really nice to have too, because currently with ARKit at least there's nothing, there's no way to detect vertical surfaces, which is limiting.
Now, does that mean that people on old hardware would have a different experience of an AR product than people with the brand new hardware?
Not exactly. Yes and no, but if you go back past 6S, just speaking in iPhones, not thinking about iPads, but just in iPhones, for example, it's kind of binary. You either have it or you don't. So pre-6S, you can't use ARKit. 6S and up, you can. The difference is, I think the difference between like an iPhone 7 and 6 is that the degrees of freedom of camera and plus moving around in the room, which I was kind of talking about before. So on the latest and greatest devices with an A10 chip, you can look at your content and walk around it and look underneath of it and move away from it and see it get smaller and bigger. On an older device that still supports ARKit, but not 6 degrees of freedom, you would only be able to see the content sort of stationary in your room and move your phone up and down, and you would see the content move up and down in your screen, but you wouldn't be able to like walk closer to it because the phone can't track your movement in relation to where the content is placed originally in the room. But as far as like horizontal plane detection goes and object detection, so that you can add anchors to arbitrary objects in the room or place them on planes, that all works no matter what hardware you're using today, as long as that hardware supports ARKit.
Now, I know in VR experiences, if you get something wrong, it makes people sick. But at least what I've heard about with regard to like, if the hardware is not good enough or if there's some mistake in the stitching algorithm when they're trying to stitch together the virtual reality environment, if something is off, people can detect it and they just get sick. Does that happen with these ARKit experiences?
I think based on the hardware, so these are like physical. Yeah, so I think the difference between ARKit and VR experiences is kind of like physical and hardware based. So part of the reason why people get sick in VR experiences is that those experiences do cover your entire field of view, and you are also looking at something that, when you're looking at something that takes up your entire field of view, your cognitive, your subconscious, cognitive processing is very sensitive to things like that. So things like refresh rate and resolution matter a lot more But what we're seeing with ARKit specifically, given that it's on a 2D screen in front of you that's not necessarily taking up your entire field of view, a lot of those problems don't necessarily present themselves in the same way. There are things that might like break your sense of immersion in AR. If, for instance, Jesse mentioned that like if you don't do occlusion properly, things might not look like they're situated in the real world. But as far as looking at a screen on an ARKit, those like motion sickness type issues with VR don't necessarily carry over. But when you get into things like AR glasses and eyewear, I think that's where like your visual and like cognitive senses come back into play.
Yeah, I think the bigger problem may be once this rolls out to many, many millions of end users and not just early access developers, people holding up iPods, walking down the street and running into telephone poles or something like that, because it's very much about moving around. But even then, I think that way ARKit's sweet spot and what it's really designed for is sort of tabletop visualizations of like a game board or some sort of animated object like a dog or a robot moving around in a room like the size of your living room. And it's something like, so you just said, it's something that you have to hold up a device in front of your face to be able to see the scene. So it's probably in that sense a little bit easier to use and less likely to make you sick.
Incredible. So, I was under the impression that we were going to need AR glasses to have really compelling AR experiences. But after seeing these things on Twitter, like there's this Twitter account that's made with ARKit Twitter account. I'm sure, it's just a content aggregator basically, but it's really cool. If people want to see some samples of the coolest AR stuff, well, I'm sure there's other aggregators at this point because this stuff is so cool. But if you have not seen AR stuff, you should stop this podcast right now and go check out some of the ARKit stuff. It's just breathtaking, to be honest. And it makes me feel like, okay, glasses are going to be great, but do we actually need AR glasses to have what is essentially like a platform shift, like what I would consider as important as a platform shift? What are your guys' thoughts on that? Like, if people are just, like, let's say, because there's also rumors about, Apple's going to release glasses by the end of the year. Whatever, maybe it'll happen. Maybe Google Glass is kind of coming back into the fore. Maybe Google Glass will become a consumer product soon. But let's assume neither of those happens in the next year or two, and we just have AR applications on our phones. How impactful is that? Like, how important is that?
Yeah, I think it's a super important stepping stone. I personally think that AR glasses will still be compelling in terms of use cases. I think one of the good things about ARKit and the demos on like iPhones and iPads is that it's very easy to share what that looks like via like a video or an image. It's much more difficult to express or to actually like represent what an AR glasses experience actually looks like via video or image, which is why I think like it's harder to capture people's imagination or get people excited about that type of experience. I think especially in the next year or two with ARKit on screens, it'll be a very important way to grab people's like mind share about what is possible with AR. I think especially with, the kind of AR conversation that happened a couple of years ago around glasses, like I think people are hesitant to or skeptical about the kind of how impactful an AR experience could be and like how useful or practical they could be. So I think like one of the really exciting things would be to like show some actual like really practical use cases for AR and getting people excited about AR and used to it before, like the glasses arrive.
Yeah, I totally agree. And I think that, we really kind of probably have to wait and see what the hardware looks like and how kind of intrusive it is in people's lives. But I'm interested in it because I've been thinking more, working at Mapbox, thinking about location and kind of, I feel like we're kind of like pushing the boundary a little bit when we think about location and AR and ARKit. Again, because ARKit, I think, was kind of built more for the tabletop, like in living room use case. But if you start thinking about use cases for walking outside and wayfinding, tourism apps, like, sort of taking the Yelp monocle idea of like being able to hold up an app and see what's around you and expand on that a lot more, add in a lot more data layers, like what we have at Mapbox. I think it would be, for me, really fun and interesting to be able to have that experience outside without having to hold up a flat screen in front of my face to do it. But again, I really think we'll have to wait and see like when and if and that hardware comes and what it looks like.
Well, let's talk more about what's going on today. I want to work in a conversation about Unity, and then we'll get to Mapbox and some of the things that people are actually building, including yourselves. We glossed over Unity a little bit, but I know Unity is a 3D. Basically, you can make 3D models in it and do other 3D things. I think maybe 3D animation. Can you explain how Unity fits into this conversation, and what is the Unity SDK that works with ARKit?
Yeah, so I think where Unity fits in is to enable like a specific class of content. So I think Jesse mentioned earlier that working with a native iOS SDK, would you describe it as mostly like a 2D kind of focus?
Yeah, you mean like the ARKit part of it specifically?
Yeah, working with ARKit and Xcode in terms of creating content.
Oh yeah, for sure. I mean, working with ARKit and Xcode requires that like you're it's basically just working with code compared to looking. I think I know where you're going. Like when you're working with Unity, it's a much more visual experience usually.
Yeah,
and that doesn't really exist in Xcode. It exists in terms of model creation, but not like what you're doing.
So where Unity fits in is I think it opens up a like different class of applications being able to be developed. So working with like inherently like 3D techniques, so 3D models, 3D simulations, like particle systems, physics simulations, it makes that a lot easier and like lowers the barrier of entry a lot to creating AR content using those techniques and those systems. And yeah, you don't have to necessarily like the interaction becomes not for the developer at least isn't necessarily like working with lines of code, but the developer are more like visually focused and focused on content creation in that way. And the Unity ARKit kind of plugin essentially are just hooks that combine the same like API calls that are available in the the native iOS ARKit SDK into being accessible within Unity. So controlling the Unity camera via ARKit is essentially what that kind of unlocks.
Okay, so what have you used this Unity ARKit plugin for? Like, I guess, kind of give a breakdown of an example of how it's used, and I guess kind of how the abstraction layers fit together.
I guess as a user, I can speak to that. So I created a scene. I think it was last month of some location in Hawaii. So using our Unity SDK at Mapbox, I created a 3D scene that was a terrain mesh of like a beautiful looking cliff overlooking the ocean in Hawaii somewhere. And that scene is completely possible to put in a game, sort of in the traditional sense. So Unity allows you to publish your content out to Xcode or Android Studio. It actually generates projects for you, so you can play that content and look at it on the screen like you normally would, using the ARKit plugin or bridge combined with the Unity, the Mapbox terrain mesh Unity scene that I made. I was able to express how I wanted, sort of where I wanted that to appear and what size I wanted it to appear in the ARKit scene and place it in that scene. And kind of, I guess ARKit kind of does the rest, but it really just, like in a nutshell, allows you to bridge your classic 3D content that you'd create in Unity into an ARKit scene on an iPhone.
Cloudflare runs 10% of the internet, boosting the performance and security of millions of websites. Many of you probably already use Cloudflare on your sites, but we're not talking about using Cloudflare today. We're talking about building on top of it. If you're a developer, you can build apps which can be installed by the millions of sites which rely on Cloudflare. You can even sell your apps. They can make you money every month. Your users can log in or register to your service inside your app. They can get a real-time preview of your tool live on their site, and they can start paying you monthly, all from within Cloudflare apps. They can go from never having heard of you or your service to having it installed on their site and paying you in seconds. Visit cloudflare.com/sedaily to watch how you can build and deploy an app in less than 3 minutes. That's cloudflare.com/sedaily. Thank you to Cloudflare for being a new sponsor of Software Engineering Daily. Okay, well, let's get into Mapbox because that's where you guys work, and I think there's some very interesting integrations across these different tools that we're describing because I think we're kind of taking a scattershot approach and then we'll bring them together. So explain what Mapbox is and what kinds of applications people build with Mapbox.
So at Mapbox, we're like a location services platform. And so what that kind of entails is everything from web maps to geocoding, which is location search, to directions and routing. So that's like driving directions, walking directions, and biking directions, as well as satellite imagery. And we also have, and since we're a platform, you can host and manipulate that data on the Mapbox kind of platform. And to give access to that platform, we're a SaaS company, so we have a REST API, and then we have various like web, native iOS and Android, and Unity SDKs, as well as a few other SDKs to allow access to that API and all that data and our web platform.
And I think a lot of people... Oh, sorry, go ahead.
No, please.
I was just going to say, I think a lot of people in the mobile space come to us for an alternative to Google or Apple Maps SDK that they can drop into their applications. And they do that because the maps that we provide via those SDK clients are really highly customizable. So like literally every pixel of the map at every zoom level, you can customize to be whatever color you want, use whatever font you want. You can inject content into the map, and maybe even more importantly, you can inject data into the map. And like Siyu was saying, host that kind of arbitrary data on our servers or on your own, and the map, when it's rendered on the phone, is rendered as a map, and the user sees that there's a lot more behind it. So all this arbitrary data that you've associated with various points on the map can be queried and rendered in different ways, like 3D buildings and with various types of overlays for data visualization.
And one thing that we've seen on the Unity side is we store a lot of our map data as vector data. So using kind of polygons, points, and line segments to build out what constitute like roads, building out lines, points of interest, things like that. And since Unity itself is a renderer, we've seen Unity developers really take that data and really manipulate it in ways that are pretty low level and customizable for them. And so it's been interesting and exciting to see what happens when you get people access to that low level data.
I know this conversation is mostly about AR, but I'd love to know a little bit about how Mapbox is built because, thinking about it more, this seems like a really complex API tool set to build. If you're doing things like building really detailed maps and, you've got to, I guess just talk a little more about how that's what goes into building a mapping SDK. It sounds like I can just imagine there's so much data that you have to keep updated. For example, like I know Google Maps, for example, I've talked to some people who work on that, I think, or I've listened to some interviews about it, and there's so much upkeep involved in keeping location data up to date and so on. Can you just talk about like how engineering at Mapbox works and how you keep an API competitive with Google and Apple?
Yeah, do you want to talk about maybe sort of leading up to the SDKs and OpenStreetMap and stuff, and I can kind of take it from the GL and mobile side?
Sure. Yeah, so before I started working on the Unity team, I worked a little bit on our platform team and our satellite team. So I think one way to think about Mapbox is just there are like the SDKs that give access to the platform, and then the platform itself is a lot of back-end server-side programming. So for our kind of map data, we source our GIS and mapping data from a number of different sources. The largest one being OSM, which is OpenStreetMaps. It's kind of like a Wikipedia, but for maps. So individuals can go and contribute mapping and location for their neighborhood, or municipalities will sometimes upload their like civic records. And we also have a large data team that contributes data to OpenStreetMaps as well. And so we have a pipeline to ingest all that data on like a constant basis. I think the turnaround time for something being live and edited in OSM to being live in our Mapbox maps is something like on the order of 10 minutes. So it's a constantly updating kind of live map that we do QC and validation on. And that all that GIS data is hosted on AWS in like a GIS based database. And so when you make a map request, our maps are broken down into individual tiles based on where you're looking and like what level of detail you're looking at. And so that goes into AWS and sends you kind of the tiles that you request. And those tiles get stitched together by the renderer, whether that's your browser, whether that's the GL renderer in our native SDKs, that gets stitched together as a mosaic to make the map. On the satellite imagery side, and also for our 2D like raster maps, instead of vector data, that's all like raster images that we store and are delivering to you as individual raster images that gets pieced together.
Yeah, and then on the SDK side, so you just talked about at the end of the day, everything that is the backend is kind of communicated to the mobile SDKs in the form of vector tiles, which is a way of describing to the mobile SDK rendering system what information it needs to know to be able to draw the map. So instead of just sending images over that make up the map and stitching them together, it sends a compressed data stream, and that data stream is turned into drawing primitives by the rendering engine, and then those eventually form a map. And all of that code is written in a cross-platform C++ implementation for the native mobile side. So our Android and iOS and Qt platform bindings all share that common code base. And again, that common code base it's really its main job is interfacing with OpenGL and drawing the map. And then that implementation is wrapped in platform-specific code and APIs to make it really easy to use. So instead of a developer having to take our C++ cross-platform engine and plug it into their map, they can take that wrapped up in a nice Objective-C++ wrapper on iOS, for example, and that gets exposed very nicely in a Swift API. So it feels a lot like the kinds of map SDKs you'd be using, sort of incumbent on the platform, like Apple Maps and MapKit and Google Maps APIs. And then I think it kind of goes full circle. So once developers take the Map SDK and use it in their application for showing a map, that information, the way the user's interacting with the map, the problems that they're having. So we surface ways for end users to be able to note issues with the data that they're seeing. There's some anonymized location data that's sent back that we use for things like traffic, free flow traffic speeds and things like that that kind of contribute back to our navigation stack. So it's really, I kind of see this environment where what's happening on the server, the data that's sent to the server and used by the Maps SDKs on the client side map applications on phones is kind of in turn plugged. The data that those SDKs are able to get from end users is plugged back into the system, and it works really well that way.
Yeah, I also wanted to mention that while that part was focused on maps, other parts of kind of the platform include like geolocation searching, so that's geocoded searching, and directions and routing. And one of the things that we're thinking about, especially in relation to ARKit and AR in general, is kind of thinking about location services and more than just rendering a map, and thinking about like places and points of interest as kind of geodata that people are interested in that don't necessarily need to be rendered in the form of what you think of as a traditional map. So some of the information that is available in these vector tiles are also like metadata about buildings. So like the name of the hotel you're at, the address of the hotel, also like any parks that are near you. We call that like land use. So parks, waterways, lakes, rivers, things like that are all available to you as data. And so thinking about how to render that data in a way that doesn't look like a traditional map, or like in ways that are fed to you as information via AR, is something that is exciting for us to explore as like a platform.
Well, let's explore that a little bit more. I can think of many reasons why I would want to use a mapping API with augmented reality. For example, let's say I'm running an application on my augmented reality glasses and I'm just walking down the street and I want to be able to see interesting things along the way. Like you mentioned, I think there's a Yelp application where you can basically hold your phone up and see information about different restaurants around. And I mean, the reason that you know where those restaurants are, or your smartphone knows, is because it's using some sort of mapping API and it knows your location, or at least you can tell me if I'm wrong. It knows your location your geolocation relative to the geolocation of restaurants that you're looking around at, so that it can sort of serve information that's superimposed on your vision. Talk a little bit more about the integrations between augmented reality and mapping and how that translates to projects that you guys have worked on.
Yeah, so at the end of the day, we're really developer tooling companies, so we want to make it easy for developers to make those kinds of applications. And I think ARKit is a piece in the puzzle that now allows us to build our own SDKs and sort of libraries on top of. So that Yelp application and others similar to that were relatively difficult to do without larger engineering teams or a bigger budget. But with ARKit and data and tools from Mapbox and others, I think we're really going to see that kind of use case democratized and made a lot more easier for people to access. And I think we've been focused in the last few weeks, at least, on thinking specifically about libraries, additional missing pieces that we can add to make that kind of thing easier. An example of that would be, with ARKit, like we talked about before, the session is started, and that, assuming everything goes well, the phone can tell where it is with respect to where the session started, and that's that origin is at 000 and sort of X, Y, and Z space. But as the phone moves around, the delta from where it started is noted in meters. But if you wanted to draw a red box over the top of a building that's visible in that scene, that red box may represent a building that you have from map data that's expressed in a latitude and longitude. So the challenge then for the developer would be to say, well, I know where I'm at in latitude and longitude, and I know where that building is in latitude and longitude, but how many meters is that away from where I am? What direction? What's the bearing of that point in space? And how high up? How tall is it above ground level? And how tall is the building? And do I want to have the box float above the building or in the sidewalk right out in front of it? And do I want the box to have sort of a label? And what kind of information do I want to say about the building? So all of those types of things, those are the kinds of tools that we will build to make using Mapbox data to augment ARKit actually really easy to do. And then we'll see what developers build with the things that we make to make their lives easier.
And yeah, from kind of like a high level, the way I've been thinking about it is that ARKit is really good at creating experiences based on kind of the room you're in and the kind of environment that's immediate in front of you. But I think the really compelling thing about Mapbox is that it can provide you with the contextual information of the world that goes beyond that room. So like things happening down the street, things happening across the city, and things happening across the world. And connecting that to ARKit is kind of where we're at and what we're thinking about as a team right now.
Well, let's zoom out even further and talk about the broader implications of augmented reality and how this is going to look over the next couple of years. First off, a little speculation. Do you guys have any understanding of what the go-to-market strategy is going to look like for augmented reality? Like, do you have any ideas for how Apple is going to roll out this stuff, how Google is going to roll out this stuff, and maybe the implications for developers who are thinking about jumping into this space?
I can think of a few. I don't know, my personal opinion is that what's been made available to developers right now is sort of purposefully been put out there to as kind of a test to see what happens and to see what kind of content people create and to kind of warm up the market a little bit. I think that's really good in a lot of ways. Like I'm looking forward to the App Store this fall in a way that I haven't been in a really long time, because I think it's going to be a lot more like it was back in 2008 when there were just kind of a lot of goofy, silly things that people were making, and people are just going to kind of explore this space. It's, we've talked, people have been working in this space for a long time and working really hard to make this possible. But the fact that it's going to be so easily accessible to so many developers is going to be really interesting to see. And I think, I think there'll be a lot of things that sort of come and go, but over the course of the next year or two, even in the complete absence of any lasers on phones or special glasses, I think that probably start to see some focal points in that market and some really interesting use cases. As far as that goes, like from the software perspective, I think that games is an obvious one. That's been talked a lot about already. I do think that even though it's a little bit of a stretch, sort of outdoor point of interest finding, like we've talked about, is interesting, but also wayfinding and certain use cases for navigation, at least pedestrian navigation, maybe even biking, but that may be a stretch without the right kind of hardware. And then, as far as a larger go-to market strategy for the platform providers, I do think it'll probably become clearer as the market sort of fleshes out what kinds of apps make sense in this space and what don't. But yeah, I guess the go-to market would probably be real dedicated hardware that doesn't look too silly, that allows you to experience these applications without having to have them so abstracted like they are now, sort of in a 2D screen.
Yeah, and just anecdotally through like casual conversations with people that have been working in this space at smaller companies, not Apple and Google, I think they're excited by the prospect of this as well. Just like getting more developers interested in AR is good for them, because you'll just have more people thinking about the techniques and the use cases for AR, and just having more developers that are knowledgeable in that space will help the more independent like hardware and software creators for AR. It's definitely like a rising tide raises all ships situation.
We talked about some different tool sets that are important to the world of augmented reality. ARKit, Unity, Mapbox. What else is changing in the developer tool space that's exciting to the two of you in regards to AR?
That's a good question. I think we've kind of covered a lot of them, especially since we are so focused on maps and location at Mapbox. The ones that you just mentioned are probably the most important to us. I guess I'm finding it interesting to see to watch the aggregator that you mentioned before, the Made with ARKit feed, and see what people are doing with, and think about what did they use to do that. Like I have some knowledge of how I place content in from the physical world in the scene, but there are some demos out there that are really truly amazing, and I think they're probably pieces to the puzzle that I just don't know yet.
I think all those things that you listed are exciting because we are at a point where that's easily accessible to a large number of people, both on the development side and the end user side. I think one area that'll be interesting to see what comes up is more ways to interface in AR. Right now it's like a touch screen, but things that I've seen around are like a stylus or a wand that allows like the device to get feedback either through motion or like through camera detection. Another kind of input devices I've seen is like a ring that you can scroll with. So yeah, just AR itself is a new kind of interface, and just thinking about more ways to get feedback.
Okay, so to close off, I have kind of a random thing that I want to do. I haven't done this in the past, but AR is such a big shift, and you guys have been thinking about it as much as anybody lately. So I've just got kind of like a rapid fire thing, 5 or 6 topics, and I'm curious for how you think augmented reality affects each of these areas. So maybe you guys could take turns responding to these. I've got like 6 or 7. Let's just go through them real quick. Okay, so first of all, YouTube.
I can't think of a way that YouTube changes too much other than as a place to share the kinds of things that you're doing. Sort of like sort of content sharing platform.
Yeah, based on some of the things I've seen in like glasses in AR, like if you're wearing a glass, you can like be watching a YouTube video while you're walking down the street and not interrupt that. Not the safest thing, but a new way to interact with YouTube.
Side note, I walked into a telephone pole earlier this year when I was looking at my phone. So I don't even need the AR glasses to do this. I've seen some horrible videos of people getting into accidents doing this too. But
so YouTube will be used to see more people walk into telephone poles with their iPads.
Right. Podcasting.
Yeah, I think one thing that would be interesting is to do like remote podcasting. So like you could have an avatar or a person from a visual perspective, you can kind of like hologram in someone and doing podcasts remotely, but having both people show up on the same screen.
Advertising.
I think probably I've already seen some made with ARKit demos about advertising, but I think there'll probably be a potential explosion there where applications existing social media applications that have advertising platforms will allow will make it possible for advertisers to post content like sort of like billboard like content in the real world. I'm sure that could be gamified too, and people would probably be potentially, at least in the beginning, a more interesting advertising experience to go have some sort of scavenger hunt to find something or to see something about a brand projected in a 3D space where you are somewhere in the city that you're in.
Yeah, it's totally the Minority Report use case too, where like you have a billboard that shows different things to different people.
Okay, so lastly, how do you think the augmented reality shift will impact Snapchat and Facebook, and will they respond to it in the same way or in different ways?
Well, I think both of those companies are kind of already in the game, especially in the with Facebook and Instagram. And Snapchat, the Snapchat app, users are encouraged to use augmented reality to filters to kind of decorate the images and videos that they're posting. So I think that won't change because it's already happening. I just think I think maybe it'll change because this sort of thing will exist. It'll be easier for developers to add to other applications, so it'll be potentially a little bit more normal. Like a larger base of users will be more comfortable with adding that kind of content into their applications. And again, kind of getting back to advertising, maybe like a larger set of advertisers would be interested in augmented reality content on those applications.
Yeah, this might be a little soft and it's definitely like a future thing. And I think probably the way that Facebook and Snapchat are thinking about augmented reality is that creating like a more passive user interface so that end users are constantly engaged in the platform. I think that's something that Snapchat especially tries to do more of getting users more like opening up the app all the time. So like if you were in an augmented reality kind of future where people always are used to like having interfaces that are always on, Facebook definitely is a logical choice there, but like I think Snapchat would love to be like in that kind of conversation as well.
All right, guys. Well, it's been great talking to you. I have really appreciated the range of topics from Mapbox to all the engineering building blocks to your speculations on the future. So I look forward to seeing more out of Mapbox, hopefully more demos related to augmented reality.
Yeah, thanks again for having us. It was really fun to talk about.
Yeah, thank you.
Look for a job more efficiently with Indeed Prime. Indeed Prime flips the job search model and lets you find a job more efficiently even while you're busy with other engineering work or coding your side project. You simply upload your resume, and in one click, you get immediate exposure to companies like Facebook, Uber, and Dropbox. The employers that are interested will reach out to you within 1 week with salary, position, and equity up front. Don't let applying for jobs become a full-time job itself. With Indeed Prime, the jobs come to you. The average software developer gets 5 employer contacts and an average salary offer of $125,000 through Indeed Prime. It's 100% free for candidates. There are no strings attached. Sign up now at Indeed.com/SEDaily. Thank you to Indeed Prime for being a repeat sponsor of Software Engineering Daily. And if you want to support the show while looking for a new job, go to Indeed.com/SE Daily.
Wow.